So let's briefly talk about attention. Attention is how we humans understand and carry context dimensionally over time or within other contexts. When we don't pay attention to perception, we miss important context and understand less or get confused. Attention is the first step on the pathway to advanced cognitive AI for today's AI systems. There are a number of critical elements to artificial attention, such as learned weight vectors, embedding and encoding, but there are also a number of new techniques for artificial attention being developed, such as artificial self-awareness and deep contextual designs and multi-dimensional layered contextual relevance. I cover some of these newer designs in the Superintelligence bootcamp, so if you're really interested, you can go into that one. For now, just know that there are a lot of new designs on the whiteboards in labs regarding attention. And in fact, right now, there is a plethora of PhD papers being released on artificial attention. Now you can think of embedding as an abstract layer of data providing more info about an element of data, such as relevance to other elements. Key and query vectors are the vectors of all the input words and one specific word. For example, measure the relevance of one word to all other words, with the weights or relevance already learned in training on a corpus or large word data set. So in the query, what is a dog? Dog is the critical contextual key, along with the call to action context of what is. That is carried as attention or focus by the system as mathematical attention scores. And it uses these to generate tokens. This is generative AI. So that is what it's doing. It's generating output based on its attention. So once again, softmax is used at this point to produce most relevant values between words or word relationships in the input data. The weighted sum is the perception of simplistic context, but be aware, not deep cascading context, just simple unidimensional context. That level of context, like the deep cascading context, takes different layers and different architecture. So this is the standard model of artificial attention today, but once again, there are others. So this slide goes a bit deeper into attention in natural language processing. Now note that attention of the kind we see here is also critical to all perception, including comprehending video or streams of context, or flowing computer vision cognition such as autonomous driving, etc., etc. Attention is also the input of generative models like ChatAI, ImageAI, and MusicAI, etc. All rely on the ability of the system to carry focused context, or attention, from a text prompt through to a response. You can see the overlap to transformers going on. The encoder-decoder structure in transformer architecture for natural language processing is run in a stack, with the output usually a set of learned matrix weights sent to a decoder. The stack formation permits parallel operations against an input vector, or a prompt, to use a word corpus index to identify existing classifications of words and to identify relationships within the prompt to the generative response that is needed. The decoder will use a relevance proximity to hold focus on the most relevant encoder outputs. So it's basically looking at all the words in a prompt, roughly 9 at a time, and how each token relates to the 4 words in front and the 4 behind, and then it time steps ahead, and it generates a response in the same general way. It will begin its response with a high relevance words like a dog is, and then generate the next word as the token with the highest weight of relevance, i.e., what word is most likely to follow the phrase, a dog is? This is one structure, but there are new structures in design, and of course, deeper learning cycles, or more parameters and weights, can also improve this. So this is what we see on this slide, wherein the attention focus eventually becomes the context over various time steps, some longer and some shorter. This provides the natural variance in the conversation or consistent response over long outputs, i.e. paragraphs. It also provides the foundation of very long context and variant response over multiple input stimuli or queries, just like we humans do when we sit down with a friend over lunch and carry a flowing context that progresses over time. This is something OpenAI is still struggling with because attention is very resource costly over time, especially if it is deep or layered. It's why ChatGPT responses are limited and why longer conversations sometimes devolve, as I have posted online. It is also a way to push the AI to the breaking point, which I've unfortunately done with surprisingly good results. So next we'll take a closer look at the guts of ChatGPT and DALL-E.